Alright, so we first start off vector triangles by understanding how to plot them on a graph and find their coordinates. Yes, all vectors have a starting point and a direction. And the question that came in class a lot today was, don't the arrows just go on forever? Well, in a sense they do. The motion just continues on, but what we're measuring, the arrow is just an indication of direction, and what we're measuring is an increment of time. We're catching the vector in this increment of time of where it's at in relation to its position. So over here, this vector is going to start here at this point and end at this point from what we're analyzing it. Remember, the arrow is just there for us to know the direction. So we'll measure this one at 1, 2, 3, 4, 5. On this scale, I'm going to use centimeters. So this would be 5 centimeters east because the indication is that the direction is eastward. Let's go ahead over here and take a look at C. For C, we're going to look at 1, 2, 3, 4, 5, 6, 7, 8, 9 measurements in a direction southward because the arrow indicates that it is going south. What's interesting here, though, is with the diagonal vectors. They can either go diagonal this way, that way, south, east, and northwest, all over the area. That we focus mainly on an angle, and the angle, let's move that aside, is for this particular one, the information given to us is northeast 30 degrees. But what you also notice is that with diagonal vectors, we sit here and see a right angle being formed. So we will bust out the trigonometry and use the Pythagorean theorem and the SOHCAHTOA methods, which is what we're going to get into today. So real quick, let's just go ahead and do a really quick Pythagorean theorem question. We have one vector that's going eastbound this way at 5 kilometers per hour, and we have another vector going north. Where you at? There we go. At 7 kilometers per hour. Our resultant will be a squared plus b squared equals r squared. We want to find out the result of both these vectors interacting with each other. And we just simply do that. We plug and play a squared plus b squared equals r squared. And remember, we must always do, please excuse my dear Aunt Sally, parentheses, then exponents, then multiplication, division, and Aunt Sally would be addition and subtraction. Do not sit here. I know one of you will do this, but don't do this. You will sit there and add 5 plus 7 and then square it. What you'll end up with is 144 because 5 plus 7 is 12, and then if you square that, that'll be 144. Don't do that. Exponents first. We're going to multiply 5 times 5, then 7 times 7. We get 25 plus 49, and we get 74. As far as your work is concerned, what I'm personally looking for, and if you are part of someone else's class, you have to make sure with your teacher what it is that is considered work. You don't have to give me that, okay? You have to give me one of these. You have to show me that either 5 squared or 25 is part of your work. You don't have to show me the 74, but I do need to see that square root. Trust me, if you just follow these rules, you will actually catch your own errors and everything will be nice and dandy. What I also forgot to label here is the direction of this resultant. This one is going northeast. If we check back a little bit here, it's northeast simply because the vectors interacting with each other are pushing north and east that way. So, once again, I need one of those, I need one of these, and I need that. And box your answer. One more time. We do not want to play Where's Waldo with where your answer is. I'm grading literally over 100 tests, and I cannot sit there and just search for your things. I think you're special, but not that type of special. Anyway, we're going to keep on moving. So we're back to the right triangle. We're going to be dealing with the right triangle quite a bit. First, we're going to visit tan. tan theta is the opposite leg over the adjacent leg. And really quickly, let's go over the acronym. And you can pause the video. I might even put, I think I'm going to put a subtitle for this. The acronym that you need to know for all right triangles is SOHCAHTOA. If you didn't learn this in geometry, know it now. SOHCAHTOA. This is the acronym for right triangles. SO stands for sine equals opposite over hypotenuse. C stands for cosine equals adjacent over hypotenuse. And T stands for tan equals opposite over adjacent. Now, a lot of you in class were wondering, what is that sign? You should know the sign by now, but it's okay. That's why we're here. This sign is a theta sign, and all that is the Greek term. It's a Greek letter, and we use that for the representation of angle. We can't use A because later on you'll learn that we use A for acceleration. So we had to use, so A is in physics here. It's just a weird, awkward representation for just an angle. So whenever we see this 0 with a line through it, that's what I call it. 0 with the line through it equals angle. Okay? So tan multiplied by the angle equals the opposite leg divided by the adjacent leg. In a triangle, the adjacent leg is the leg that's connected to that angle, and the opposite leg is the one that's not used in the angle that you're talking about. So we're talking about this angle. The leg that's not used is this one. These other two are used. Remember that this long leg in every right triangle that is not part of the right angle is called the hypotenuse. If you don't understand what I just said, please rewind that and re-listen to. So let's move on. Here is a wonderful example of using tan theta. What is the direction of a resultant? So we're going to focus on the hypotenuse, the resultant. If a wind is blowing east 24 centimeters per second, so the wind is blowing at 24 centimeters per second, and then there's another wind blowing south at 30 centimeters per second, what would the resulting wind be? Now, as you can see here, we are moving eastward, and this one's moving southward. But what you notice is that here, the southward vector is labeled with a negative. The reason why it's labeled with a negative, as we discussed in class, is that we base our vector coordinates on a north-east-southwest scale, which I'll show you in a second. And with the we use the north and south directions for the y-axis, and we use the east and west coordinate plane for the x-axis. So we simply just plug and play. Your equation will look like this. Tan theta, opposite, this is our opposite leg. That's at negative 30. This right here is our adjacent leg, and that's going to be at 24 centimeters. And we need to get theta by itself. So remember, this is tan multiplied by the angle equals opposite over adjacent. We need to get rid of tan, so that's where we come up with our function of tan to the negative 1. Remember that a negative exponent makes it a derivative, or it kind of divides it by that many. I'll give you an example of 10 to the first power equals 10. Okay? But 10 to the negative first power equals 1 over 10. It equals 1/10. You divide it by that many times. So to get rid of tan, this is the same thing as putting everything in parentheses, right? And canceling out tan this way. Those cross out, but what you do to one side, you do to the other. That's the equivalent. But instead, we're just going to use the tan to the negative 1 function on your calculator. So let's get back really quick about this negative vector. The first question people will ask is, well, if that is going to be a negative vector, won't the whole thing be negative and we have a negative angle? Well, now we have to start getting familiar with negative angles. Okay, so now let's go ahead and deal with how we deal with negative angles. Over here we have 4 quadrants on our north, east, southwest scale, and we're using it very similar to just calling this our y-axis, and this way is going to be called our x-axis. Okay? So whenever we have a negative angle, you have to, what that really means in physics is that we're moving downward in a clockwise rotation. Normally, our positive angles are measurements that go in a counterclockwise position, and they can continue going beyond 360 so long as it keeps on rotating forever. Now, this is just a regular physics class, so we're not going to get into too much detail there. But the way that we're going to handle this is that if we have a negative angle, we're just going to go ahead and call it a positive, and then just use the x-axis of the, or the y-axis of the x-axis. So if you have a negative 47-degree southwest angle, which means it's southwest, so it's south and west, your angle's somewhere over here in this position, and your angle's there. There's your 0 with the line through it, your theta. Then that's going to be expressed 47 degrees south of west. Please know that. Moving on. This is how we're going to define it here in your calculator. Your first step is to push second and tan to get the negative tan function. And in your calculator, the first thing you see is tan negative 1 with an open parenthesis. That means it's ready to go. And then from there, we just we stick in our other function. We input negative 30 divided by 24, and that will be right here, 24. And from this point on, you can just go ahead and push enter. But notice that you can either close the parentheses or keep the parentheses open. It really doesn't matter at this point. You should read negative 51.34 degrees. If your calculator does not say that, then if you're using a scientific calculator, you're going to push this button right here. It's called the DRG button, and you need to get it in degree. If you're using a graphing calculator, then you're going to look for this button called mode. It's in the same position next to your second button, and the mode that you need it in is degrees and normal. Otherwise, you won't see this. It's weird because if you deal with it in radicals, you get it's a totally separate math altogether. You need to have it in degrees and radicals. Also, make note that we do not push the subtraction button when we deal with making a negative number. Look right there next to your decimal point and push that for your negative 30 when you put that function in. So the way this should read is 51 degrees south of east. Box the answer. Box the answer on your quiz and tests. Now we're going to deal with the ka part of SOHCAHTOA, and that's C-A-H, which means that cosine, your theta, your angle, is equal to adjacent divided by your hypotenuse. So let's go ahead and take this example. A wagon is traveling down a straight hill, so it's traveling down a hill at 37 degrees. So my angle is 37 degrees downward this way, 47 meters. How high does the wagon descend? Start its descent. Okay, so we're trying to measure the point at the top of the drop to the bottom of the ground. So here we have an angle. We're looking for the adjacent leg, and we're given the hypotenuse. We have enough to find out what that adjacent leg is. And we start off by just boom, boom, and boom. Okay, so here, this is our angle. We're going to do cosine 37 because that's our formula. Cosine 37 equals adjacent divided by 47 degrees. So you can just simply circle cosine, or push cosine, and then type in 37, and then you push enter. So what you should see here is something along the lines of 0.79 or 8 or somewhere along those lines. What I did was I just kind of rounded it to 0.8. And now we just simply solve for x or your adjacent. And on your papers, it doesn't matter to me. If I see adjacent, that's fine. If I see x, that's fine. Some people just cannot break the habit of solving for x. It gets kind of tricky later on, but that's okay. For now, that's fine. So you simply solve for x. We're dividing by 47, so we're going to multiply both sides by 47. On this side, they cancel out. You simply punch that in your calculator, and your answer is 37.6 meters from the ground. So that's how we found out you're adjacent. And the last part of SOHCAHTOA is the sine function, which is sine theta equals the opposite over the hypotenuse. And if you notice, all my hypotenuses are always going to be in yellow. And if we can clearly see here, this is the angle in question. We're using the hypotenuse and the opposite leg. The leg that's not being used for that angle is the what we're going to be using as far as the sine functions are concerned for right angles. Okay, so let's go ahead and get this out of the way. We have a river that flows west, but the water is actually moving northwest. And we want to find the direction or the angle at which this is moving. So we need to find the angle or the direction that this is moving at 14 meters per second. So we have enough. If this is our angle, we have an opposite leg over here and a hypotenuse, and we just simply plug those into our sine function. We don't know the angle, but remember, we're going to have to use the inverse or the negative exponent in order to figure out what theta is, because we have to divide both sides by sine. Okay, so moving on, this is exactly how you do it. Going through the first step, we once again push the second function, and then we're going to push sine to get the sine -1 function. On your calculator, you should see sine -1 with an open parentheses. Then right after that, you just simply input your opposite divided by your hypotenuse. So over there, you're just going to put -5 divided by 14. And one more time, spank your hand. Do not do that. Don't push minus. Go ahead and push your negative sign there. And when you push enter, you get -20.92 degrees northwest. Remember, we just simply go north of west. Box your answer. So this is what I'm looking for on the test. If you didn't get any of this right now, just please email me or talk to your teacher, whoever your teacher may be. But this is pretty much how you handle right angles in vectors.